Oh, good morning, guys. I'm waiting for people to come in. And we're all coming in at one time here.
Hello.
Hi. How you doing, Haley?
How are you?
Good. See, I think I got more coming in somewhere. Okay, so I got Haley and Tori. That's the three of us. Is that breakfast or lunch?
Breakfast.
Or snack. All right, there's somebody else. It's Anai. Oh, anybody got any concerns or questions right now?
Well, I have a question about the quiz, but I don't know if you want to talk to me after class.
Let me get on. I'll tell you what. Let me get online and look at it, so you can ask me a question, and I'd rather answer it in front of everybody, so everybody has the same kind of help on it. So.
Well, I just don't know. Like, I did everything except for on the interval -1 to 4 because I was going to wait and do that on the graph, but I guess I'm.
Okay. Well, I do have a suggestion about that, Haley. Don't worry about the interval yet. Don't worry about the -1 to 4. Just do the whole graph.
But that's the thing. I don't know how. I don't know how. I just don't know how.
You don't know how to do the whole graph and then cut it off?
Well, I know how to do that. It's just I plot the inflection points and then all the other stuff. It just doesn't match up.
Okay.
So I don't know if I did something wrong or if I just.
All right. I tell you what. Let me. I was going to start with one of those in class today, so maybe that'll help. And then if it doesn't help, you can ask me individually about it. Okay.
Okay.
We'll do that. Anybody else got any? While we're waiting for everybody, anybody else got any questions?
No.
Okay. All right. All coming in. Okay. Okay. Well, I'm trying to let Stephanie in. I'm not sure. Lainey, there you are. I'm not sure you're in yet. You must be.
Yep.
Yep, you're in. Okay. Okay. So go to this different view here so we can see who's here. What I want to do today, guys, I do want to start out with one like the one that's due for homework. And the one that's due for homework is a quiz about sketching graphs and doing all those things I ask you on that. I'm going to do an example and then I'll look back at that quiz and see if I see anything different about it or whatever. So let's look at under the homework on Monday. I had I want to do the one that I wrote out, which was number 3. It was this one. Let me share my screen with you guys, and then let's just go through a whole nother one of these and see how it works. Okay. Hopefully it's coming up. I don't know why it's paused. Come on. Okay. Nobody's waiting to come in, and for some reason I can't get it. Ah, there we go. There it is. Okay. And somebody else waiting to get in. Hang on. That's Emily. Get that out of the way. Let me get her in. Okay. All right, good. She's in. I'm going to start out on a page here. This was let me see. Let's see what I can do on this one. I'm trying to find some blank space here I'm going to work on. That ain't gonna do it. Hang on. Kind of don't want to do that. Let's see. Let's go down here. That's not a good one to do. Hang on a second here, guys. I'm trying to find a blank page. Here's the problem that I want to do is number 3 under the homework on Monday. The function is f of x equal x to the 4th minus 2x squared on the interval from -1 to 3. If you've got access right now to your assignment sheet, that's what I'm looking at. This one, let's see what I got here. Okay, here we go. So here's the one I want to do, and I'm going to carry it through everything. This is like the quiz that's due. Not everybody's in. Hang on. Okay. All right, I think everybody's that's waiting is in now. I'll check it again in a second. But here's the problem. F of x, and this is everything we've sort of learned for this quiz that's coming up. It's due tomorrow by class time. It's x to the 4th minus 2x squared, x to the 4th minus 2x squared, and I ask you to look at it on the interval from -1 to 3. Okay. Now I'm gonna hold on that interval thing for right now. And oops, Emily still didn't get in. Okay. Let me see if she's in. She's not. Guys, let me email her. Hang on a second. She's not getting in. See if I can email her. So while I'm doing this, guys, does anybody have any general questions or issues? My last class was asking me about that date of next week that says whether you want to take a pass, no credit in here, or whether you want a grade. I'd like to talk to everybody individually about that. So that would be, shoot me an email before then if you have any particular concerns about which you should choose, and I can talk to you about what I see your grade as right now, and what you might want to do. Hang on one second. Let me see if I can get her in. 2, 6, 3, 9, 8, 7. Okay. Okay. So it's different for everybody, whether you want to take a pass, no credit, or whether you want the grade. So just let me hear from you if you have a question about that. And the one thing that I will say is that this grade in the end, this decision in the end is not 100% binding on you, because in the end, at the end of grades, I can go in and change a grade. And somebody got told in the last class that it would take months to do that. It's not going to take months to do that. And even if it does, I'll write you and say it's going to get done. Don't worry about it. The ones that have to worry about it are the ones that are sending off recommendation forms or transcripts to grad school or whatever. I don't know if you guys are in any that shape or not. Mostly it was my majors that are worried about this. But please let me know if you have concerns about that. Emily, are you here yet? I just don't see her. Oh,
yeah, I'm right here.
You're here. Okay, I couldn't get you in. Did you have trouble? Did you have trouble with the password or something?
No, I entered the password. It said that I was in the waiting room for I don't know.
Okay, I kept clicking on admit.
Almost 10 minutes, yeah.
Oh, I'm sorry. I kept clicking on admit and I couldn't get you in. So I just shot you an email with the password in case that was the problem. Okay, all right. So no problem. So guys, if you have questions for me, please feel free to email me and we'll discuss it. I mean, if you want to, we don't even have to discuss it over email. You can give me a phone number. We can talk about it over the phone. Whatever. I don't know I mean, email's secure, I think, but whatever, who knows. So what I do want to do about this is, on this one right here, let's go ahead and just get started. On this, I want to just go through all the processes that we've learned, less the asymptotes. I have not, none of this involves any asymptotes. As a matter of fact, the place where I would start on this thing, it's not there, okay, right there. The place where I would start on this thing is asking you what the domain is. And the domain on this thing, it's a polynomial. It doesn't have any bad points, zeros and denominators, anything. The domain is from minus infinity to infinity. So that's pretty easy. Now, what we need to do at this point is take the first derivative. So that's 4x cubed minus 4x. And we need to be careful with the derivative. We need to factor the derivative. So I can take a 4x out of this one. And it's got x squared minus 1 in it. Once you get that done, you want to make positive and sure that you get all the critical numbers. I would suggest to get all the critical numbers, you completely factor it. So x minus 1 times x plus 1 here. Okay. Now, the reason I say that is because there are actually 3 critical numbers here. Where would 4x be 0? Well, it would be 0 when x was 0. There's another root here of 1 and another one of minus 1. I've had several people on one or the other of the quizzes that did not factor this, and they said, oh, the only solution is 1. But that's not the only solution. There is another solution, it's minus 1, and you will see that if you factor. Okay. So once I get those critical numbers, I'm going to put them on the number line. So in order, minus 1, 0, 1. So in this one, I've got 1, 2, 3, 4 regions to check. It's not, do not put any other points on this line other than the critical numbers, because it'll just junk it up. Don't put your test points on there. Just either keep those in your head or put them off to the side somewhere here. For instance, if I said, let's test 2, and I don't even care at this point whether it's in this interval, okay? Although we will be going from one interval, one place to the next. But right now, if I test 2, 4 times 2 is 8, 2 minus 1 is positive, 2 plus 1 is positive. Positive, positive, positive means I've got positive there. Immediately, I know it is increasing. Positive first derivative, increasing. Between 0 and 1, say a half. 4 times a half is positive. A half minus 1 is negative. A half 1 is plus 1 is positive. I'm testing it in the derivative. I got a positive, and a negative. That's going to give me a negative. That tells me that it is decreasing there. To the left of 0, between minus 1 and 0, I'll try to plug in minus a half. 4 times minus a half is negative. Minus a half minus 1 is negative. Minus a half plus 1 is positive. So I've got 2 negatives and a positive. 2 negatives and a positive give me a positive. All right. So there, I know it is increasing. To the left of minus 1, again, I may or may not be interested in that, but we'll worry about it in a minute. Minus 2 would make that negative. It would make that negative. It would make that negative. I'm plugging in minus 2 for x. 3 negatives multiplied together give me a negative. Decreasing. So here's all I can get from that number line. I know I'm going to write this stuff out in interval notation. It's increasing between minus 1 and 0 because it's positive. The derivative is positive there. Union 1 to infinity. It's decreasing in the other intervals, and that would be from minus infinity to minus 1. Union 0 to 1. That's the first thing I get out of this. The next thing I get out of it is local maxes and local mins. If you look at minus 1 and you're looking at the critical numbers, if it's going down and then up, that's a local min there. So we say there's a local min at x equal minus 1. It is whatever you get when you plug -1 into the function. So I'll go back to the function. -1 to the 4th is 1. -2 times -1 squared is 2. 1 minus 2 is -1. So that's what the local min is. It's -1. Let me double check that. -1 to the 4th is 1, and then -2 is -1. Right here at 0, there's a local max. Look at what's happening. It's going up on the left and down on the right. So local max at x equals 0. Local max at x equals 0. It is f of 0. And if you plug 0 into the original function, you will get 0. So that takes care of 0. If you look over to 1, going down, coming up, that's another local min. So local min at x equal 1, it is f of 1. If you plug in f of 1 right here, you'll get 1 to the 4th minus 2 times 1, which is 1 minus 2, which is also -1. Looks like you got local mins that hit the same bottom part. Now, another thing that this has given you guys, and this is important because you're going to need it a little later on the graph. These are giving you some important points. This one is giving you a point -1, -1. You'll graph it in the end. This one is giving you 1, -1. This one is giving you the point 0, 0. Okay, so that's what the first derivative tells me. Is there anybody that has a problem with that? Are we okay? I'm just kind of trying to look at you, but I don't, it's a little hard in some cases. Is everybody okay with what we're doing there? The next thing I'm going to do is find out all the information about concavity. And I'll do that by looking at the second derivative. So f double prime of x, go back to where you took the first derivative here before you factored it, right here, and take the second derivative. That's going to be 12x squared minus 4. 12x squared minus 4, okay? Now, I need to do the same thing here. I need to set it equal to 0. And I could pull a 4 out of this. So that's going to be 3x squared minus 1. And that's equal to 0. Now, this isn't very pretty here, guys, but that thing right there needs to be 0. Because there's no way that that can be 0 because there's no x with it. It's just a 4. Don't make a 0 there. There's not a 0 there. But this is not hard. This with the algebra, it's not pretty, but it's not hard. So 3x squared minus 1 equals 0. 3x squared equal 1. X squared equal 1/3. Just dividing. That says x will be plus or minus the square root of 1/3. Don't be intimidated by these. It's just not very pretty. And that, let me go up a little bit here. If I put the square root of 1 over the square root of 3, it's actually going to be equal to x equal 1. The square root of 1 is 1. So plus or minus 1 over root 3. Now, if anybody's got a calculator, I'd like for you to find out for me what 1 over root 3 is. So we'll get a little bit of an estimation here. I want what 1 over root 3 is, and let's just do it on your calculator. Tell me what, my calculator is in the other room. Tell me what it is, and we'll check it with everybody. What is it again, Haley? What is it?
0.58.
0.58?
Yeah, I rounded it.
Okay, that's fine. I think it's about 0.5880 or something like that. So
yeah.
It's plus or minus about, we'll say 0.58. Okay, that'll help us in the end when we just try to find a point. So I'm going to need you to keep your calculator out to help me. So I put that on a number line. So one of them is minus 1 over root 3, which is about minus 0.58. and the other one's 1 over root 3, which is about 0.58. I needed this to tell about what that value was, because I'm going to test in either one of these intervals to find out where the derivative is, the second derivative is positive or negative. So something bigger than 0.58 might be 1. So if I plug in 1 here, 3 times 1 squared minus 1 is positive, times 4 is positive, so I get this concave up. Between these two things is going to be 0. That's nice, because if I plug in 0 here, it leaves me with 4 times minus 1. That tells me concave down. Over here to the left of minus 0.58, let's just plug in minus 1. Minus 1 squared is positive 1, so 3 minus 1 will be positive, times 4 is positive. So that'll be concave up. Okay? So I'm going to write that in its intervals. So it's going to be concave up from minus infinity to minus 1 over root 3. Usually we'll use this exact value there, guys. Union, and we know what it is, but we can use it, but we usually write it like this. That's concave up. Concave down is going to be in between minus 1 over root 3 and 1 over root 3. Okay. Is everybody with me so far on this? Speak up if you have a question. There's one other thing I can find from the concavity graph. And the concavity graph tells me inflection points. So inflection points are places where the concavity changes. Okay, so it's pretty clear from this line right here that the concavity changed around these points. So the concavity, concave up on one side, concave down on the other side, right around there it changes. So one of those inflection points, and I'm going to make this as simple as possible here, one of those inflection points is going to be about minus 0.58. And because we're just going to graph this one, you can put in the minus 1 over root 3, but we're going to plug this in. Now, remember where we plug it in. Here's where I need your help with the calculator again. Go up here, right here to the original. You want to find the y coordinate of the inflection point. So I want you to plug in minus 0.58 to that. And I'm going to go get my calculator, guys. Plug in minus 0.58 to this thing right here, minus 0.58. I'll be right back. I was trying to do my taxes last night, so I had this calculator there. And then I decided, why am I doing this now? I have until July 15th. So the rule is, I do it now when you can put it off till later, especially if it's taxes. So let's plug it in. Let me see if I got what you guys got. I'm going to minus 0.58 to the 4th power. And then I'm going to go minus 2 times that. So it's 0.58 again. Did you get minus 1.04, guys? Take the speaker off.
Negative 0.559.
0.559? Where did you plug it? Let me try again. Anybody else get something different? 0.5, I put in 0.58. That's 1 divided by root 3. Let me double check that. Okay, 0.58. 0.58 to the 4th. Minus 2 times 0.58. Oh, I didn't square it. I think you're right. That's my problem. Hang on, let me double check. So it's to the 4th minus 2 times 0.58. And it'll be the same if you put in 0.58 minus 0.58 because it's even powers there. But I do want to square it, which is what I forgot. Minus 0.559. Is that about right? Minus 0.559 is what I'm getting there. Confirmation on that? Is that, Haley, you were doing it. Anybody else? Confirmation on that? Get your mic off and tell me, somebody.
I got that as well.
Okay. All right, good. Thank you. Okay, so let me go back down to where I was here. On the concavity, it's going to be minus 0.58 and about minus 0.56. We'll do it like that. Okay, that's one of the inflection points. Another one of the inflection points is 0.58. Okay, so 0.58. I'm looking at my line right here. And then if I plug in 0.58, I'm also going to get minus 0.56, guys. This is not pretty, but those are inflation points. And we'll graph them and we'll see what it looks like. We'll make a scale and see if we can make it look better or look okay. So, so does everybody, when you ask for an inflection point, guys, they are asking you for a point. Unlike with local maxes and mins, where you're saying the local max is the y value, it happens at the x value. Now, what I'm going to do next is make a master line, and then I'm going to try to graph this thing. On my master line is 0, 1, minus 1, because they all came from the first derivative critical numbers. And then these other two concavity numbers, okay? And one of them's minus 0.58. So I'll put it right here. It's a little over a half there, minus 0.58. And right here, 0.58. Okay, so all the numbers that were important in the first and the second derivative, I'm going to put on this master line. Now, please stop me if you don't understand what I'm doing here. If you can do this one, you can carry through, you can do all of them, okay, if you're careful with your derivatives. Now, remember what happened back on the increasing and decreasing, and I'm going to roll back for a minute. On the increasing and decreasing, everywhere to the right of 1, it was positive. 0 to 1, it was negative. Minus 1, 0 to minus 1, it was positive, and then negative here. So I'm going to write down what that says. It was decreasing. I'm literally going to write it. I'm not going to put pluses or minuses. I'm going to write it was decreasing to the right of 1. Everywhere between 0 and 1, it was decreasing. So even though I've got this extra, no wait, it was increasing there, sorry. Let me go back and look. I hate this where I don't have it where I can keep it on my board. It was decreasing to the right of 1, yeah. Increasing to the right of 1. Sorry, there it is right there. Increasing to the right, there it is right there. Increasing to the right of 1. Wrote that wrong. Okay, so increasing to the right of 1. In between 0 and 1, it was decreasing. Now, because this thing got split up by that concavity plot spot, I'm going to put decreasing. Everywhere in between 0 and 1. Everywhere between 0 and minus 1, it was increasing again. I'm going to go back and check that. Let you look at what I'm checking. So there's the increasing, decreasing graph. So between 0 and minus 1, it was increasing. And to the left of minus 1, it was decreasing. It was decreasing. Okay. Now I'm going to put the concavity stuff on. Does everybody understand what I did there? I'm sort of ignoring the concavity thing there. I have to look at every interval though, because concavity might change here. So increasing everywhere to the right of 1, in between 0 and 1 decreasing, 0 and minus 1 increasing, left of minus 1 decreasing. Now let's see if I can go back and look at the concavity. To the right of that 0.58, it was concave up. So what I'm going to do, to the right of 0.58, everywhere in those intervals, I'm going to write concave up. I'll go back down again here. Between those minus 0.58 and 0.58, it was concave down. So in between here and here, it was concave down. The rest of the time, less than that 0.58, it was concave up. Okay. So the master line is important. Is everybody seeing how I'm putting all the information that I've got on this master line? It's going to help me draw things. So here's what I want to do. I want to draw the shapes there. And then I'll put the points on the graph and I'll connect the shapes. So I'm going to put down here what I think that shape is. Concave up, decreasing. Now remember, decreasing means, look at the cursor here, guys, that my cursor's coming down. My hand's coming down as I write this. So it's going to be in that direction. Concave up means it's going to be bowed upward. So the shape right there looks like that. If you look at the next piece, it's increasing. My cursor has to be rising from left to right in a concave up fashion. So rising left to right, concave up, looks like that. Okay, that's that shape. There's only 4 shapes, guys. This one is increasing concave down. My cursor has to come up, but it's bowed downward. Okay. Concave down, decreasing, cursor's coming down, bowed downward. Concave up, decreasing, means my cursor's coming down, but it's bowed upward. So that one looks like that. And finally, concave up, increasing, cursor's coming up left to right, bowed upward. Okay. If I tag those pieces together in the end with the points that I've got, I will have the picture of the graph. So what I want to do right now is draw the picture. Is anybody having trouble deciphering the shapes? Are you okay with that? Okay, let's see if I can get a graph here. Let me put the points that I have on here. I have the point -1, -1, 1, -1, 0, 0. Here's where I'm going to start to draw. Put the points on there. I have, let's see, let's make a bigger scale here. Hang on. Suppose that's 1. Dang it. Wait a minute. I just did away with my graph. Hang on. Here's my graph. X, Y. Let's let that be 1. I don't want to get it. Let me do one. Do it again. I'm going to need all the way up to 3. So here's what I'm going to do. I'm going to go 1, 2, 3. There's 0. There's -1, -2, -3. I'll go like that. Here's 1. Here's -1. Now, let's see if I can do something without erasing it. I'm going to plot the points. I need to look at them again because I don't have a very long memory these days. -1, -1, 1, -1. -1, -1, 1, -1. So -1, -1. So that's right there. -1, -1, 1, -1, and 0, 0. I'm just putting these points on here so I have something to tag things onto, guys. I have another couple of points. Remember the inflation points were 0.58. And what went with that was the point minus 0.56. We got 0.58 and minus 0.58. So 0.58 was minus 0.56. So right down here is that one. I always want to label, but I'm sort of running out of room here, guys. That one's the 0.58 minus 0.56. That's an inflection point. And the other one was minus 0.58 and minus 0.56. So it's right there. So I'm ready to draw the graph. That's all the points I've got to work with. What this thing ultimately looks like is this. Let's look at the master line and see what it tells us to do. The first thing it tells us to do to the left of -1 is come down to that -1 in a concave up fashion. So let me do that. It's coming down in a concave up fashion, guys. So that shape looks like that. Okay? That shape, that's decreasing concave up. If you look at your master line next, I want to still stay concave up, but I go increasing till I get to -0.58. Oops. So here's what that shape looks like. It looks like this. Increasing, concave up, till it gets to the 0.58 spot. Look at your master line again. I've got the next shape is concave down, increasing. Now, let me point out something here, guys. This is not a drastic change. It's very subtle. This is an inflection point. Don't put a bunch of wiggles in it, okay? You don't want a bunch of wiggles in it because wiggles means it's constantly changing concavity. This one's up here and then down there, very subtle. I think if you look at the next one, between 0 and 0.58, it's decreasing concave down, okay? If you look at it, you'll see that. Decreasing concave down, and the next one is concave up, decreasing. So a very subtle change here. It's still decreasing, but it's gently bowed upward. Okay, now what did it do after that? We'll see. What it did after that was it increased and went concave up like that. So it's looking like this. Generally looking like that, guys. Now, let me talk to you about the rest of the problem. A couple of things. Look at that. Those are local mins. That's a local max. That makes sense in terms of what we did. Okay. Now, the only thing left to do here is to cut it off where they asked me to. And where they asked me to cut it off, if you remember from the very beginning of the problem, it asked me to look at it on the interval from -1 to 3. So I want to look at this thing. I want to cut it off right here. I want to cut it off at -1. And then I want to find out where it is by the time I get to 3. Now, this might be out of sync, but I'm going to try to do that. I'm going to try to find that point. And then I'm going to try to erase some selective things. We'll see what that happens. What do I do to find out where it is at 3, guys? Open up your mics. I'm tired of talking for a minute, for at least a second. Where do I go to find out what the point is at 3?
Plug in 3 to the original equation.
Okay, I go to the original equation. So the original equation was x to the 4th minus 2x squared. X to the 4th minus 2x squared. So I'm going to just write that up here to remind myself. X to the 4th. X to the 4th minus 2x squared. I'm going to put 3 into that. 3 to the 4th is 81 minus 2 times 3 squared minus 18. And 81 minus 18 is 63. So actually my scale is really pretty bad, guys. But what happens here is I'm going to just go ahead and label that point. It stops way up there at 63. Did everybody get that? I just kind of did it real quickly.
Yeah.
Okay, good. So at 3, it's up here at 63. That's a bad scale. But anyway, there you go. We can kind of see it. Now, on the other side, it stopped at -1. So they really didn't want any of that part right there, okay? So it's easier for me, and I think for you guys, if you'll graph the whole thing and then chop it where it needs to be chopped. And then you can adjust your scale, whatever you want to do there. So here's the question. Now here I'm going to answer one more question. Tell me what the absolute max is on this function? Anybody? Tell me what the absolute max is.
363.
Okay, now we don't say 363. If we're asked for a max, we
Oh,
say it's 63. It occurs at 3. Okay, you got to remember that. That's a little hard to remember. But what we'll say is the absolute max. The absolute max is 63. It occurs at x equal 3. That's like saying the profit's $63. I should make 3 of these things. You want to put it in a real world context. Okay, next question. What's the absolute minimum value on this interval? What's the absolute minimum value on this interval?
Is -1 occurs at 1?
Okay, so the absolute min, close. The absolute min, remember it's a y value, it's -1. It occurs actually twice. So we would say it occurs at 2 places, not only just 1, but at -1. 1 and at x equal -1. That's like saying the maximum profit for this company occurred in 2 different years. Okay, so it's the same level of low down there, guys, but it just happens to happen at 2 different places. That is everything I can think to do with that one, except that there are no asymptotes here because there are no x's in denominators and it's not a rational function. So the stuff we added on about asymptotes is not relevant here. Okay, questions, anybody? So that's probably the most complicated one you had on the homework in those 3 that I wrote. So there's a key to it. I followed through every step I could think of, guys. Is there anything you don't understand? All right. So if anybody has any additional questions at the end of class about, wow, which is pretty close, about the quiz, I'll answer those questions, and everybody can hang on the line if you want to hear this discussion. All right, so here's what I want to do. Oops, I don't want to do that. Let's do this. I'm gonna say a little more about asymptotes here, and then do a little bit more on asymptotes, and I'll do more tomorrow. Okay, we'll put it all together tomorrow. Everything we've done. Let me say to you that there was a problem in your book that I saw that I kind of liked, and I can't put the whole thing on here. This was on the page where we did asymptotes, and it asked you to match these graphs with the particular function down here. So let me review what I did yesterday and talk a little bit more about horizontal asymptotes and vertical asymptotes too. And we'll do as much as we can, and then we'll save it for tomorrow. These problems right here have no vertical asymptotes because there is no value of x that makes the denominator 0. This is not x to the x squared minus 1, which would factor. It's x squared plus 1, and it won't factor. Now, let me say one more thing. In order to be able to find out where horizontal asymptotes are, and then I'll show you sort of what they do, we need to find a common denominator. So the common denominator on this one is x to the 4th plus 1. This will be 2 times x to the 4th plus 1 plus another x squared. So if I find a common denominator there, I just gave the 2 the same denominator as the other one had. That's 2x to the 4th plus 2 plus x squared over x to the 4th plus 1. Now, hang on to that for just a second. And again, I'll say it. In order to find the horizontal asymptotes, you've got to get a common denominator. The common denominator in this one is going to be 5 times x squared plus 1 minus 1 over x squared plus 1, which will be 5x squared plus 5 minus 1, which will be plus 4 over x squared plus 1. Now, here's what I'm going to ask you, and we're going to talk about it in review, guys, and then I'll look at what I've got above the sheet. to find horizontal asymptotes, horizontal asymptotes are lines or asymptotes that have equation y equal. Don't get that mixed up. Y equal is horizontal, x equal is vertical. What we do is this. We look at these rational expressions. What happens if the power in the numerator is the same as the power in the denominator? The highest power, I should say. The degree of these two things is the same. What is the horizontal asymptote? How do you find it? Anybody? You looked at your homework last night. The powers are the highest power is the same as the highest power in the denominator.
It'd be 3.
Yeah, it's 3. And the reason for that is if they're the same, you look at the coefficients on those highest powers. Y equal 3 is a horizontal asymptote. How about this one? What's the horizontal asymptote on that one?
2.
Yeah, notice again, you've got 2 over 1 here. So y equal 2 is the horizontal asymptote there. This is another one. What's the horizontal asymptote on that one? That's easy. Again, 5 over 1 is 5. What's the horizontal asymptote on this one? This one's a little different. The power in the numerator is, the degree is 1. It's the highest in the numerator. The highest in the denominator is 2. What happens when the degree in the numerator is less than the degree in the denominator?
Y equals 0.
Y equals 0. That's because the denominator is getting bigger faster than the numerator. It's overpowering that. And if you get a bigger denominator in a fraction, it's getting closer and closer to 0. So what your book asks you to do in this problem, and I didn't assign it, I don't know why, because I didn't see it initially, but here are the asymptotes we got. We got y equal 3. We got y equal 3 for number 1. The way I've got these labeled, which one has an asymptote of y equal 3, guys? A, B, C, or D?
D.
Yeah, the horizontal asymptote, and see what it looks like. Horizontal asymptote is the horizontal, and the tails of the graph get closer and closer to that. That's what a horizontal asymptote does. It describes this end behavior. So D gets matched with this one. So that one is D. Which one has a horizontal asymptote of 0? Look at them again. Which one appears to have a horizontal asymptote of 0? Michelle, I see your light on there. Undo your mic and tell me which one you think.
B.
B, yeah. See, the horizontal line y equals 0, look, y equals 0 looks like that. It's just the x-axis. So that one right there gets matched with B. Okay. The next one had an asymptote of 2. So that's C. Which one appears to have an asymptote of 2, guys? Anybody?
A.
A. All right. So A, notice there's the horizontal line right there running through 2. So A gets matched with this one right here. And finally, right here, y equal 5. There's only one place for it to go. But look at the way I got it. I've got it drawn. It clearly looks like C. That's the horizontal line passing through 5. So C is the last match. Okay. Does everybody understand what I did there and what a horizontal asymptote looks like and how you find it? Now, one other thing, I didn't have an example here, but if the power in the numerator, the highest power in the numerator is higher than the highest power in the denominator, there's no horizontal asymptote. It's not getting closer and closer to anything. It's just blowing out of proportion. Okay, one other thing we'll call it quits here. I wanted to start this with going through some graphs that had asymptotes in them, and I'm just gonna say a couple of things. Let's answer a couple of questions here, and then we'll leave it till tomorrow. Tell me what the domain of this function is right here. What can't x be?
2.
X can't be 2, right? Because of that denominator, I mean, down there. If you let x be 2, you get an undefined form. So that domain is -∞ to 2, union 2 to infinity. Now, guys, this is in fully reduced form. There are no holes in the function. There's nothing to cancel out. The domain really tells you what the vertical asymptote is. X equal 2, it'll pop up at the same places you have to kick out on the domain. So there's X equal 2. Somebody look at that and tell me what the horizontal asymptote is.
1.
1, because you got, look at the highest power in the numerator and the denominator is x to the first. They both have a coefficient of 1, so y equal 1. I'm just going to find the x-intercept right here. If x is 0, guys, then the function is minus 3 over 2 or 3 halves. I'm not going to, 3 halves. I'm not going to graph this one today, but I'm going to get it set up for tomorrow. Here's what I want to look at. What we've got is a vertical asymptote of 2 and a horizontal asymptote of 0. So getting it ready for tomorrow, here's what the graph ultimately is going to look like. Actually, I'm going to leave a little more room here. A lot more room. We're going to draw the graph of this thing eventually. It's got a vertical asymptote of x equal 2. It's got a horizontal asymptote. And actually, I'm going to put those asymptotes in a different color there. There's that. And the horizontal asymptote was y equals 0. Your graph has to fit into that picture so that it tails off in the end close to this one. And near 2, it either shoots up or shoots down. And that's what I want to talk about tomorrow. So I'll call it quits for today. Anybody that wants to ask me a question or listen in on Haley's question about the quiz, you can do that. Anybody else, I'll see you tomorrow. Haley, you're up. What's your question?
I think I'm just gonna redo the quiz, and because
Okay.
I when I was doing increasing and decreasing, I looked at the derivative instead of the original function. So I think that messed my whole.
Oh,
entire
yes, that will, look, if you're testing where it's increasing and decreasing, be sure you're putting your test points into the derivative, okay? And that'll give you the increasing, the plot pluses and minuses, you need to do that.
Oh, I did that.
What was it you didn't do then? I didn't.
For the increasing and decreasing, when I was doing the test points, I plugged them into the first derivative. Is that correct?
Yeah, that's right. If you're doing increasing, decreasing, you plug in your test points to the first derivative. And if you get a positive, that means it's increasing in that interval. If you get a negative, it means it's decreasing.
Oh.
Let me look at something here. Let me look at the quiz a second. Hang on. Let me find the quiz here. Oh, where'd it go? Quiz. Can't find it on my Moodle, so I know it's on there. Well, tell me what the quiz. Wait, oh, there it is. I see it. I'm sorry, it was in this week. Okay, so I'm looking at 4x cubed minus x to the 4th plus 9. That's what you're looking at, right?
Yeah.
Okay. So find the critical numbers, pull out, make sure you get that thing factored right and you test it right. I think when you factor that derivative, that you're going to get you're going to be able to pull an x squared out. An x squared, when you test it, no matter whether it's negative or positive, is going to be positive. So be careful when you plug in your test points. That might be a problem there. Okay? So be careful.
Should I, when I plug in the test points, I plug it into
The first derivative. If you want to find out about increasing and decreasing, you plug the test points into the first derivative in its factored form, as far as you can factor it.
Oh, okay. As far as you can factor it.
As far as you can factor it, right? So factor out whatever needs to be factored out and look at what's left and then put it into those pieces of the first derivative.
All right.
Does that make sense? I think I probably can guess what you've done wrong. You may not have factored it far enough, or you might have skipped over the fact that one of those things was an x squared.
I'm just gonna redo it all.
Okay.
Print off another copy and then
Okay, that's
see if I
fine.
have any problems.
That's fine. Tori, you still on? You okay? You got any questions?
No, I'm good.
Okay.
I was just listening.
Okay, that's fine. Jennifer, are you okay with this? Cut your mic off.
Yes.
Yeah, you okay?
Yes.
Okay, good. So be careful with the derivatives. And then you got to do the concave up. Try to make a master line and then try to get a graph of the thing. Now, keep in mind that you want your graph to match whatever the calculator says. The calculator's not going to be wrong, but you also want the information that you got here by doing the increasing, decreasing to match. So it's not going to be very good if you come up with the right graph, but all your information above was wrong, because that's not the point of this, okay? The point of this is to get all the information to match what the graph ought to look like. Okay, so anybody else? Any other question? All right, then I will see you guys tomorrow, okay?
You.
You got class
All right.
tomorrow?
No, yes, you got class tomorrow, right? Everybody's got class. Tomorrow's Thursday, yes. All right, see you then. Oh my, got me confused.
Bye.
Bye.